Okay, today we're going to solve exponential equations by using logarithms. Let's go ahead and take a look. Okay, before we can start doing solving, we need to talk about the change of base formula. Calculators can't do logarithms of any base. They only can do it if it's the natural log, which is base e, and they can do a common log, which is base 10. So in order to do that in the calculator, we can use this thing called the change of base formula. For the change of base formula, log base b of a, we can rewrite that and plug it in our calculator as log base 10 of a divided by log base 10 of b. So notice the base of your original log goes on the bottom, and that's how I remember it. Base goes to the bottom. Okay? So if I looked at my first example, log base 3 of 27, we can rewrite that in our calculator as log base 10 of 27, or just log of 27, divided by log of 3. Notice how that original base, 3, went to the bottom. Now, when I do this in the calculator, make sure that you put the 27 in that parentheses. Make sure you close it, or it'll kind of throw your calculator up. So when I do that in my calculator, I end up getting 3. Okay. Now let's look at the second example. Okay, log base 5 of 22. We can write that as log of 22 divided by log of 5. Okay, now in our calculator, we're just going to type that log of 22. Make sure you close the parenthesis, divided by, so log of 22 divided by log of 5. And you should, on your calculator, end up getting 1.921. It was 205, so I ran it to 21. So those are your answers for the change of base. We're going to use this later on. I'm going to go ahead and skip example 3. Let's go on to the next slide. Alright, so solving exponential equations, here's our steps. So notice these steps are kind of similar to what we did yesterday, except they're kind of backwards. So yesterday we had logarithms and we wrote them as exponentials. Today we're going to have an exponential, and we're going to first step is rewrite it as a logarithm. Now I wrote this down here. Make sure that the exponential is isolated or by itself, okay, before you actually rewrite it. Now second step, we're going to apply the change of base if we need to. And then step 3, we're going to solve for x. Now let's apply these steps onto these next examples. Alright, so first thing I'm going to do is rewrite this as an exponent, or as a logarithm. So I'm going to do this as log base 16 of 100 equals 3x. Right? I'm just rewriting this as a log. Okay. Now if I look at this log base 16 of 100, I can rewrite that using the change of base. That's going to be log of 100 over log of that base, so log of 16 equals 3x. Now I'm going to go ahead and plug that into my calculator, that log of 100. Make sure you close that parenthesis when using your calculator. So we'll do log of 100 divided by log of 16, and we get 1.6609, so I'm going to round it to 1. Okay, equals 3x. Then I'm going to go ahead and solve for x, so I need to divide by 3. Okay. So x equals 0.554. Alright, here's our next example. So same thing, we have this exponential. We're going to go ahead and rewrite it. So this is going to be log base 6, okay, of 12 equals 0.5x. Okay. Now let's go ahead and use the change of base to figure out what this guy is right here. Okay, so we can write that as log of 12, or that big number on top, and then divide by log of our base, or the smaller number, 6. And by big and small, I mean like physically bigger. Like if you look, this 12 is physically bigger than the little 6 that's the base. Okay, not in value. So let's go ahead, that equals 0.5x. All right, now let's go ahead and divide that log of 12 divided by log of 6. Okay, so we get 1.387 about, okay, equals 0.5x. Okay, now I'm going to divide by 0.5. So x equals roughly about 2.76 0.74. Hey, I'm gonna go 3 decimals on this, so that's my final answer. Okay, for this one, if we look, okay, same thing, it's just an e, so we're gonna go ahead and rewrite this. Okay, so we go log base e, but think, when I do log base e, we don't write it as log base e, we're just gonna use ln. Okay, so ln of 15 equals x minus 5. Okay, now if you look at your calculator, we could do the change of base, but our calculator has the natural log or the ln button on it. So these ones actually, when you use e or you have to use natural log ln, we can just hit that ln button of 15 right in our calculator and we get 2.708, okay, equals x minus 5. Now I need to go ahead and add 5 to both sides. So my answer is x equals 7.7, let's go 08. Okay, there's my answer. All right, so for these ones, when it's e, we can rewrite it as ln, and it kind of saves us a little bit of steps when we use our calculator. All right, so we looked at problems like this, compound interest. So how many years should you invest $3,000 in an account with annual interest rate of 7.5 compounded continuously if you want to have $6,000? So compounded continuously right away tells me that we're going ahead and going to use a equals p e to the rt. It tells us that we're going to use that PERT equation. Okay, I'm going to go ahead and list them out on top. So a, that's our amount after our ending amount, which is 6,000. Okay, our p is our starting amount, which for this one is 3,000. Okay, our r is our rate, which for this we need to move it over 2 spots, that decimal, so 0.075. And t, we don't know t. Okay, we don't know at the time. That's what we're trying to find, how many years. Okay, so I'm going to go ahead and plug in my information that I have. Go ahead and pause it and put that information down or write that down. Okay, now this is similar to what we just did. First I need to get this e to the 0.05t by itself. So I'm going to go ahead and divide by 3,000. Okay, so I'm going to have 2 equals e to the 0.075t. Okay, now this is just like the last problem we did. We can rewrite this as an exponential or as a logarithm. So log base e, well, remember log base e we can write as ln, okay, of 2 equals 0.075t. Okay, now ln of 2, we can go ahead and put that in our calculator. It ends up being, I'm going to come up here, but it ends up being 0.693, okay, equals that 0.075t. Now I'm just going to go ahead and divide by that 0.075t, or 75 I mean. Okay, so when I divide by 0.075, I get 9.2, or about 9.2, and we're talking about years. Okay, there's my final answer. So go ahead and give these practice problems a try on the class kick. Let us know if you have any questions. Rewatch the video if you need to.